So, lesson 7.2. This is day 2 of the unit circle and radians. So we introduced the topic the last time we were together. This is our second session on radians, and then we'll follow up with a review, followed by quiz number 7, or is it 8? Yeah, quiz number 8, sorry. So let's go ahead and take a look at this. So you'll need to be able to fill out the unit circle. This should be pretty straightforward because you've done this on the previous quiz. You know that in quadrant 1, all the trig functions are positive. In quadrant 2, only the sine is positive. In quadrant 3, only the tangent is positive. In quadrant 4, only the cosine is positive. And then if you know the unit circle, you know at 0, this is the point 1, 0. And you've got the point 0, 1, the point -1, 0, and the point 0, -1. Now, what's new to you are the radian measures. So if I look at it, I've got 30, 45, and 60. The numbers start with a 3, 4, 6. So if I go up, I've got 3, 4, 6. In radians, this is going to be pi over 3, pi over 4, pi over 6. I mean, the easy way to remember, pi is 180 degrees. So pi divided by 3, that is 60 degrees. And if you look at 90 degrees, that's pi over 2. This is pi over here at 180 degrees. And this is 3/2 pi. And then you're at 0, or you can think of that as 2 pi, 1 revolutions. Remember, 2 pi revolutions is the same as 360 degrees. And then filling out the values, this is the same thing we did before. Square root of 3 over 2, 1/2. And then square root of 2 over 2, square root of 2 over 2. And then 1/2, square root of 3 over 2. Those are our values. Then everything else just works the same. It's just that we now, instead of talking about degrees, we're talking about radians. So one of the keys with radians is just to always keep in your mind fixed that at this point that you've known forever to be 180 degrees, that is pi radians. When you make that 1 revolution, you've always thought of that as 360 degrees. That is 2 pi radians. And then if I have those as my bearing points, I can pretty much figure out what the other angles are relative to that. So let's take a look at doing some evaluation of trig functions. So sine of 9/4 pi. So the first key thing is to figure out where 9/4 is on the unit circle, and then figure out our reference quadrant for that. So you know that this is 0, okay, and this is pi over here. Now, since I've divided it into fourths, it is helpful sometimes to write this as 4 over 4 pi. Okay, I didn't change anything. That's the same thing as pi, but it helps me because this is with a fraction of 4. That's 4 over 4. And if I get all the way around 1 revolution, 2 pi, that is the same thing as 8 over 4 pi. Okay? So now the way this helps me is now, where is 9/4 pi? Is it closer to 4/4 pi, or is it closer to 8/4? Well, you know that 9/4 is 1/4 beyond 8/4. So I can tell that this angle, 1 revolution, that's 2 pi, or 8 over 4. So I have to go how much further? Pi over 4. So I have to go pi over 4 further to get to 9/4 pi. So this reference angle is just pi over 4 in the first quadrant. Okay? They're asking me for the sine function. Go back to the unit circle. At pi over 4, sine is your y value. At pi over 4, the y value is square root of 2 over 2. So this answer is square root of 2 over 2. Since I'm in the first quadrant, every trig value is positive. So that's a positive square root of 2 over 2. Tangent of 7/4 pi. I'll do the same thing. The first thing is to find that angle. So this is 0. And then at 180 degrees, that is pi. Since I'm talking about fourths, it will be helpful to think of this as 4 over 4 pi. and then 1 revolution, which is 2 pi. I can also think of that as 8/4 pi. Now I need to figure out 7/4 pi. Is it closer to 4/4 or is it closer to 8/4? Well, it looks like it is just shy of reaching 8/4. So 7/4 pi, so this is 7/4 pi, and it looks like it is just short of 8/4, which is a full revolution. So that means that this reference angle is just pi over 4. So I need to find the tangent of pi over 4 and adjust that to whatever the value will be in the 4th quadrant. So the tangent of pi over 4, that is y over x. So at pi over 4, go to your unit circle. The y value is square root of 2 over 2. The x value is square root of 2 over 2. So y over x is just the square root of 2 over 2 divided by square root of 2 over 2. And since I'm in the 4th quadrant, I know the tangent will be negative. So this answer is -1. Cotangent of -5/4 pi. So if I start at 0, and if I'm going in this clockwise direction, this is minus pi right here. Now, since I'm in fourths, let's write this as minus 4 over 4 pi, because that's minus pi. Minus 4 over 4. Well, I only have to go a little bit further than that to get to -5/4. So if I go in this direction, if that's minus 5/4 pi, that means this reference angle right here is just pi over 4. So this is the cotangent of pi over 4, but I'm in quadrant 2. And it's not the cosine, it's the cotangent. So the cotangent of pi over 4 in the 2nd quadrant. So that means go to the unit circle, cotangent is x over y. At pi over 4, the x value is square root of 2 over 2. The y value is square root of 2 over 2. So this answer is 1, and since I'm in quadrant 2, I have a negative sign. So this answer is -1. Okay, let's keep on. So the key here is you've got to switch your mind. You're used to thinking about degrees. Think about radians, and it's just a way of dividing the circle up into fractions. And the fractions you're going to see are something over 4, something over 2, something over 3, or something over 6. That's about as exotic as it's going to get. Cosecant of 7/6 pi. This is 0. This is pi. Since I'm dividing it into a fraction of 6, I'm going to call this 6 over 6 pi. That helps me realize that 7 over 6 pi is just slightly further. Okay, so 7 over 6 pi is this angle right here, which means my reference angle is just pi over 6. So I need to find the cosecant of pi over 6, and I am in quadrant 3. Okay? So the cosecant is the reciprocal of the sine function. So if the sine function is my y value, the cosecant is 1 over y. So at pi over 6, so if you go to pi over 6, that's also 30 degrees, look for your y coordinate. Your y coordinate is 1/2. So 1 divided by 1/2, and since I'm in the 2nd quadrant, that's going to be positive, so this answer is just going to be 2. On to the next one, secant of -9/4 pi. So if this is 0, if this is minus pi, and when I go all the way back around, that's minus 2 pi. Now it may help, since I'm talking about fourths, to think of this point as -4 over 4 pi. And then when I make one revolution, that's -8 over 4 pi. So where is -9/4? So if I start going clockwise, that's -8/4. I have to go 1/4 more to get to negative 9/4. So that's negative 9/4 pi, and most importantly, that makes my central angle pi over 4. So I'm looking for the secant of pi over 4 in quadrant 4. Okay? So if the cosine is my x value, the secant is 1 over x. So I need to go to pi over 4. What's my x coordinate? It's square root of 2 over 2. So what is 1 over that? So it's 1 over square root of 2 over 2. And since I'm in the fourth quadrant, cosine and secant will be positive. So this answer will be 2 over the square root of 2. You could leave it like that, or the answer is basically just the square root of 2 when you rationalize that. So remember 2 over square root of 2. If I multiply by square root of 2 over square root of 2, I get 2 square root of 2 over 2, which is square root of 2. So either of these answers would be fine for that one. Tangent of 3/2 pi. Okay, so let's think about this one. If I mark my unit circle, that's 0. This is pi over 2. This is pi, and this is 3/2 pi. So what's the definition of tangent? Tangent is just y divided by x. So on your unit circle, if you look at 3/2 pi, that's where 270 degrees is. The coordinate is what? 0, negative 1. So y over x is going to be negative 1 over 0. That is undefined because you cannot divide by 0. Okay? So again, this angle was the angle on this quadrant. Now, just like we did in degrees, there were 3 kinds of problems. One was the kind of problem we just did. I gave you a trig function and asked you to evaluate the angle. Now I'm going to give you an equation that's asking you to solve for the angle. Okay? So, sine of theta equal negative 1/2. So I have to look and see, where is the y value going to be equal to negative 1/2? Well, I know that if I look in the quadrant 1, y is equal to 1/2. That happens at pi over 6. Okay? That's where it equals 1/2. So I need to figure out, what does the pi over 6 reference angle look like where the sign is negative. Okay? The sign is negative in quadrants 3 and quadrant 4. So draw this angle. So if this is 0, and if this is pi, since I'm talking about pi over 6, let's call this 6 over 6 pi. And then when I make a full revolution to 2 pi, that's going to be 12 over 6. 12 over 6, not 16. 12 over 6 pi. Okay? So if I'm looking for pi over 6 in the quadrant 3 and quadrant 4, so I'm looking for these 2 angles. So the first angle in quadrant 3, it means I go all the way to 6 over 6 pi, and I go 1/6 more. So what's 6 over 6 plus 1 over 6? That is 7 over 6 pi. The angle that is in quadrant 4, it means that I start at 0, and instead of making a full revolution, which is 12 over 6, I stop 1/6 short of that. So what's 12 over 6 minus 1 over 6? That angle is 11/6 pi. So those are the 2 angles that give me the sine equal to negative 1/2. Cosine equal 1. Remember, cosine is my x value. So where is x equal to 1 on the unit circle? Okay. The only place on the unit circle we see x equal to 1 is at 0 degrees, so this is only at 0. You would be also correct if you made a full revolution, 0 or 2 pi for that. Okay, so those are the two answers for that. Cosecant equal -2. If the cosecant is -2, remember the cosecant is the reciprocal of what? It's the reciprocal of sine. So this means the sine of theta is equal to -1/2. Okay? And we just worked that problem. That was the first problem we did, but let's do it again just to be sure. So I'm looking for where is the y value equal to 1/2. Well, that happens at pi over 6. Okay, since it's negative, I need to figure out what does the angle pi over 6 look like in quadrant 3 and quadrant 4. So again, draw this off. 0. Pi. Since my denominator it says pi over 6, let's call this 6 over 6 pi. And when I get back and make a full revolution of 2 pi, let's call that 12 over 6 pi. So to find the angle that's in quadrant 3 and quadrant 4, so if this is pi over 6, or this is pi over 6, I should be able to reason that these two angles are 7/6 pi and 11/6 pi. Okay, so a few more of these. Cosine is 1 over the square root of 2. Okay, so cosine is 1 over the square root of 2. So cosine is 1 over square root of 2. Remember, to rationalize that 1 over square root of 2, multiply by square root of 2 over 2, and this becomes square root of 2 over 2. So cosine is the x value. Where on the unit circle do I see an x value of square root of 2 over 2? That happens at pi over 4. Okay, so pi over 4, it's positive. Where is the cosine positive? Cosine is positive in quadrants 1 and quadrants 4. So let's figure out that angle. In quadrant 1, that angle is just pi over 4. Okay? If I go to quadrant 4, so I'm measuring this angle all the way around. So this is pi. And then 2 pi is the same as 8 over 4 pi. So I don't quite make it to 8 over 4 pi. I'm 1/4 short of that. So that angle is 7/4 pi in the fourth quadrant. Cotangent equal the square root of 3. Okay, so if the cotangent is the square root of 3, then let's look at this. That tells me that x over y equal the square root of 3. Where can I get x over y equal to the square root of 3? That would be wherever I'm dividing square root of 3 over 2 divided by 1/2. So that appears to happen at pi over 6. So this is pi over 6, because you know that the square root of 3 over 2 divided by 1/2 is the square root of 3. And that happens at the point square root of 3 over 2, 1/2, which is pi over 6. So pi over 6, tangent, cotangent, where are they positive? Those are quadrants 1 and quadrants 3. So the quadrant 1 angle, that one's pretty easy. That's pi over 6. So if you had pi over 6, that is the angle pi over 6. If you are in quadrant 3, and you have a reference angle of pi over 6. So what is the angle that measures from 0? So remember, at 180 degrees, that's pi. We can also call that 6 over 6 pi. So it looks like I have to go 1/6 further than that. So that angle is 7/6 pi. Tangent equal -1. Okay. Remember our definition of tangent. Tangent is what? Y over x. Okay? Where do we see y over x giving us a value of 1 on the unit circle? Well, that happens at 45 degrees or pi over 4. It's negative. Where is the tangent negative? That happens in quadrants 2 and quadrants 4. So what are these angles? So in quadrant 2, if this is pi over 4, so here's 0, 180 is pi, or we can think of it as 4 over 4 pi. So where would I be if I were pi over 4 short of 4/4? So that's 4/4 minus 1/4. That is 3/4 pi. So that's the quadrant 2 angle. The quadrant 4 angle. So if I were measuring this angle, I did not make it to a full revolution. A full revolution would be 8 over 4 pi. I'm 1/4 short of making it there, so that is 7/4 pi. Now, the third kind of problem, just like we saw before, you're combining both of these into one. So you've got something that you know on one side of the equation, and you have an unknown on the other side of the equation. So work with what you know. So figure out what is the cosine of pi over 2. So you know at pi over 2, that is this angle right here at the top of the unit circle. So what's the definition of cosine? Cosine is your x-coordinate. So on that point of the unit circle, your x-coordinate is 0. So this is 0. Okay? So this problem turns into tangent of theta equals 0. That means that y over x equals 0. This is only true if y equals 0. So where on the unit circle do I see y values of 0? That happens at 0 degrees, and forgive me, it's not degrees, it's radians now. And then we used to say 180 degrees, that is also at pi. Okay, so if you look on your unit circle, it's these 2 points here, 0 and pi radians. Tangent of theta, tangent of pi is equal to negative cosine of theta. Okay? So tangent of pi is negative cosine of theta. Figure out the tangent of pi. So the tangent of pi, so remember where pi is on the unit circle, it's right here. So I need to figure out at that point right there, what is y divided by x? Well, you know that your y-coordinate is 0. Your x-coordinate is -1, so this is just 0. Okay? So this problem turns into negative of cosine theta equals 0. Well, the only way that can be true is if the cosine of theta is 0. Cosine is my x value. So this can only be true where x is equal to 0 on my unit circle. Where is x equal to 0 on my unit circle? That occurs 2 places. That occurs at the top of the unit circle and the bottom of the unit circle. So at pi over 2 and 3/2 pi, or 3 pi over 2. So this answer is pi over 2, 3 pi over 2. So a couple more and we are done. Depending on who is listening to this, hopefully Carter is still paying attention, and Danny as well. So I get a couple of shout outs to those guys. So tangent of negative pi over 4 equal the sine of theta. So got to figure out where this angle is. So negative pi over 4, that is this angle right here. So negative pi over 4. So that's my reference angle is pi over 4. So if I look at pi over 4, what's the definition of tangent? That's y over x. At pi over 4, the y value is square root of 2 over 2. The x value is square root of 2 over 2. Y over x is 1. So the tangent of negative pi over 4 That's equal to 1, but it's in the fourth quadrant. What's the value of tangent in the fourth quadrant? Tangent is a negative value in the fourth quadrant. So this problem turns into sine of theta equal -1. So this is just asking you the question, where is y equal to -1? Because the sine is your y value. On the unit circle, where do you see a y value of -1? That only happens at one place, at the bottom of the unit circle, 3/2 pi or 3 pi over 2, whichever way you want to write it. And I think this is the last one, okay? And you should be ready to hit homework after this. Cosine of 7/4 pi equals sine of theta. These all break down to the same thing. Draw the angle, okay? 7/4 pi. That is 0. This is pi. Since I've got a fourth, and I'm looking at, let's call this 4/4, okay? One full revolution is 2 pi. It might help in this problem to call it 8/4 pi. Now, where is 7/4? Is it closer to 4/4 or is it closer to 8/4? Well, by this point you should know 7/4 is closer to 8/4. So if this is 7/4, okay, that's 7/4 pi. That means I was only pi over 4 short of making it a full revolution to 2 pi. So this is finding out what is the cosine of pi over 4 on your unit circle in quadrant 4. Okay, cosine is your x value. X value at pi over 4 is square root of 2 over 2. So this answer is, for the cosine, it's square root of 2 over 2. And I'm in the fourth quadrant where the cosine is positive. So this problem now becomes sine of theta equals square root of 2 over 2. Okay. Now this problem turns into, where is the y value equal to square root of 2 over 2? Because that's what the sine is. So where is y equal to square root of 2 over 2? That happens at pi over 4, right? And since it's positive, where is the sign positive? That happens in Q1 and Q2. So in quadrant 1, this is sort of the trivial one, pi over 4. What is that angle? That is pi over 4. In quadrant 2, if I had pi over 4, 0, and over here I have pi, let's call it 4 over 4 pi. So this angle right here, measured from 0, is 1/4 shy of making it to 4/4. So that angle is 3/4 pi. And that is it. Okay, so guys, we introduced radians. There's really nothing new today. We're just using some of those concepts of what we did the previous lesson. You got to sort of switch gears and, forget about degrees. Forget about 30, 45, and 60. And start thinking of pi over 6, pi over 4, pi over 3, 90 degrees, pi over 2, 180 is pi, 2 pi is 360. And then be comfortable knowing that pi is the same thing as 4 over 4 pi, 6 over 6 pi, 3 over 3 pi. That will help you in navigating where these answers and where these radian values are.